All right, let's go and take a look at your homework handout. And Jamie missing you today, so if you would find your homework handout, let's see how we did on that. Number one says the perimeter of an equilateral triangle is 48 inches. Find the area. Now, a couple things here. Perimeter. What does perimeter mean? Kendall? The outside, right? So all the way around the triangle, you add it all together, comes to 48 inches. But since it's an equilateral triangle, Chris, that tells me that apparently each side must be equal. Well, right, all the sides are equal, which means each side must be
similar.
Quentin? 16 inches. Each side has to be 16 inches because it's an equilateral triangle. So when it says find the area, how do we find the area of a triangle? Coming back to Chris.
Add them all together.
Okay, how do we find the area of a triangle? There's a formula. Pencil out of your mouth.
Half BH.
Good. Half base times altitude. And once we've identified that all the sides are 16 inches, I know that the base then is 16 inches, but I don't know the altitude or the height. How might I find the altitude, the height of an equilateral triangle, Quentin? Remembering, of course, that every angle of an equilateral triangle is how big? 60 degrees. Oh, yeah, I got a 30, 60, 90. And if this base is 16 inches, how big is that piece? 8 inches. So I've got an 8-inch base. I've got a 16-inch hypotenuse. So what about the altitude? 8 times the square root of 3. And now I can find the area. Plugging it into the formula, what do we get for our answer, Audrey? 64 times the square root of 3 inches squared. How many have that answer? For number 1. Good, both of you. And questions from the 4 of you who didn't do it? Questions? All right, very easy. We've done problems involving perimeter before. We've done 30, 60, 90 before. Now all we're doing is plugging in the numbers into the formula. Let's take a look at number 2. And it says the perimeter of a square is 48 inches. Find the area. Again, remembering that perimeter refers to the sum of the sides, and we know that all the sides of a square are equal. That tells me each side must be how big, Ethan? 12 inches. And then it says, find the area. Well, for a square, what's my formula to find the area? SQ equals S squared. And so I know the side is 12, so I just plug in that 12 inches, and what do I get for the area, Ethan?
144 square inches.
There we go, 144 square inches, or 144 inches squared. How many had that answer for number 2? All right, questions on number 2. All right, number 3 says the area of a trapezoid is 56 centimeters squared. The bases are 5 centimeters and 9 centimeters. Find the altitude. So I know the bases. I'm finding the altitude, and I know that the area is 56 centimeters squared. Well, anytime you're working with area, we need the area formula. And Genesis, what is the formula for the area of a trapezoid? That'd be a triangle's a half BH. Chris, help her.
TR equals HM?
Well, yes, if I have an altitude and a median, but I don't have a median. Though,
TR.
I could find the median, I suppose.
Is it TR equals half of B plus H?
Ethan?
Half of H times B.
There we go. Heard it the other half from Genesis. There, B plus B prime. Teamwork, right? If only you could take your quizzes that way. Let's all collaborate and try to remember what the formula is. But no, everyone must stand on their own merit because that's the biblical way to do things. And so, yeah, you have to know the formula yourself. Half H times B plus B prime. And since I know the area is 56, remember we'll plug that in for the TR, equals half of h. I don't know h, that's what I'm finding. And I know the bases will add together, Genesis, to get 14. What would I do to solve for h?
You would divide away or no.
I could, but I'd rather make my life easier first.
Oh, yeah. 1 and 7.
Right, to get to, so really, Genesis, it becomes 56 equals 7h, right?
H equals 8.
Divide away the 7, h equals 8 centimeters. And there's our answer for number 3. How many had that answer for 3? All right, questions on that? All right, number 4. The diagonals of a rhombus are 4 inches and 7 inches. All right, so remember the diagonals are not equal. There's a little short diagonal here, that's 4 centimeters. There's a longer diagonal here, that's 7 centimeters. And I gave you the formula for the area of a rhombus in our last lesson. We kind of deduced it through proof, in a sense, not formal proof, but demonstrated proof. What was that formula, Audrey? Yeah, make sure you're studying that page of formulas from the class notes where you wrote out all those formulas. And so to find the area of the rhombus, if I know the diagonals are 4 and 7 centimeters respectively, probably the best way to solve this, Audrey, would be to take, to get, right, there we go, and then just multiply to get 14 inches squared per area. How many had that answer for this one? Right, questions on that?
So I was kind of doomed from the beginning because I wasn't here, obviously.
Right,
so I had no idea what I was doing the entire time, so I just pretty much guessed on every single one of them.
Okay, now there was a YouTube video you could have watched, and this you had learned before you were gone, and this you were here before we were gone, and
this one I had no idea.
Right at the end of the hour on the previous day, but you're right. This one here, we were in a bit of trouble here.
Yeah, I was in trouble with the last 4.
Well, not entirely, and we'll see why here in just a little bit. But of course, if you had taken the initiative to watch the YouTube lesson, you would have been just fine. So, yeah. All right, and so technically you were present, so it's your obligation to make sure you take care of those things. Right, questions on number 4. Does it make sense now? And of course, you'll make sure as you do rewatch that lesson that you get those that you get those formulas copied down. All right, number 5. Says the perimeter of a rhombus. Here we go back to that word perimeter. But again, perimeter tells you a lot if it's an equilateral figure, like an equilateral triangle or a square or a rhombus. So we know the perimeter is 24 feet, then that tells me that, Kendall, each side has to be 6 feet all the way around. And then it says the interior angles are 60 degrees and 120 degrees. Now here you're definitely going to want to draw a picture, because you know in a rhombus you're going to have a couple of acute angles and a couple of obtuse angles. The obtuse angles are 120, the acute angles 60. And it says find the area. There's actually 2 different ways you could go about solving this. But perhaps the most direct way, for instance, the way you would solve this if you weren't here for the last lesson, is you would remember that a rhombus is a parallelogram, right? So we could use what formula, Chris, to solve this?
PL equals BH. I was going to say, can't we just draw 2, what are they called? Diameters. 2 diameters make it a 30, 60?
We could do that if we wanted to. He's suggesting why not draw a couple of diagonals. But if we're going to solve it the parallelogram method, I don't need diagonals. I need a base, got it, and an altitude, don't got it. Which, if we draw from the vertex, there's our 30, 60, 90, right? So it's important to remember in the 30, 60, 90 to label things correctly. Of course, we know this side here in the triangle is considered class the
hypotenuse.
The hypotenuse. So it's going to be represented
X. 2x.
2x. There we go. And this little piece right here across from the 30, we would label x. And then this this altitude right here is what we would normally label x times the square root of 3, because it's across from the 60. And so if 2x is 6, then x class is 3. So this apparently comes right down to the midpoint of the base. I don't care about that though. That tells me the altitude must be
Times square root of 3.
3 times the square root of 3. So then if PL equals BH, and I know that B is 6 and H is 3 times the square root of 3, what do we get for the area, class?
18 times square root of 3.
18 times the square root of 3 feet squared. That's one way to do it. Or if...
Yeah, if I wouldn't have automatically gone to, oh, I don't know how to do this, I would have gotten this right.
Right, exactly.
But I immediately went to, oh, I don't know it.
Yeah, and then you should have gone to, oop, let me watch the video, right?
Hey, well, I did it this morning.
All right, that's the other problem. Okay, the other thought is what Chris had suggested, right? Because we just saw Genesis that if I have the half D1, D2 formula, drawing these diagonals could really help. If we remember something very important about the diagonals of the rhombus with respect to the angles, class.
They bisect.
They bisect. So since these angles were 60, once bisected, they give you some little 30s. And these 120s, when bisected, give you 60s. And of course, we already know that the diagonals of a rhombus are, class, perpendicular to each other. They form right angles. So yes, Chris, we could do that and get a bunch of little 30, 60, 90s, where since this is 6, oh, wait a second. And this is 6, 60, 60, 60. What must this be, class? Little equilateral triangle. So how big is diameter, or diagonal rather, now you got me doing it, diagonal 2? It's got to be 6. So if we're taking the formula 1/2 diagonal 1 diagonal 2, I know that the shorter diagonal is 6 centimeters, or 6 feet rather, just like the other sides are. Or we could say if this is 2x and this is x, then this is x times the square root of 3. 2x gives me 3 for this piece. That means 3 for this piece. That means 6 for the diagonal, correct? Then how big is this piece?
3.
3 times the square root of 3. It's opposite the 60. It's the x squared of 3. So this is 3. That's 6. That's 3 squared of 3. Which means the whole diagonal is 6 times the square root of 3. Right, 3 squared of 3 and 3 squared of 3 give me 6 times the square root of 3. We can take half of the 6 to get 3, and then sure enough, 6 squared of 3 times 3 gives you 18 times the square root of 3 feet squared. So either formula gives you the same answer. How many did have that answer to number 5? All right, good, Kendall. All right, questions from the rest of us? All right, makes sense now? All right. Let's take a look at number 6. Number 6 says the hypotenuse of a right triangle is 17 inches and one leg is 8 inches. Now, normally, if I give you 2 sides of a right triangle, class, we'll immediately find the third side using the Pythagorean Theorem, which is probably a good idea to do here. We have a side of 17. We have a side of 8. But it didn't say find the other side. It said find the area. Well, what is the formula for the area of any triangle? Class?
T equals half BH.
T equals half BH. But we pointed out in the last lesson that for a right triangle, the base is simply one of the legs. And the altitude has to be the other leg. Now, you don't necessarily need this special formula, T sub RT equals 1/2 L1 L2. You could just say, there's the base. I need to know the altitude, and once I find it, half BH. You don't need the special formula, but you know it helps us to kind of quantify this a little bit. But using the Pythagorean theorem, how long is this other leg? Anyone? 15, right? You would say that c squared equals a squared plus b squared. The c, of course, class is which side? The 17, right? So that's your 289, right? And then the b could be either a or b technically, but we'll just say, plug it in where the b is for 64 for the base. And then the altitude, right here, the other leg is what we'd be finding. You'd subtract away the 64 to get 225 equals a squared. And then don't forget to take the square root, right, of both sides. And that would give us 15. So either a half base times altitude or a half leg times leg ends up giving us 60. And that's inches squared. 60. Inches squared, how many had 60 square inches for number 6? All right. Ladies in the back specifically, questions on this? What happened in finding the other leg?
I got 15, but I'm not really
All right, what was your answer?
32.
32. Very interesting. Okay. Not quite sure what happened there. All right. Kendall? I think somehow, Audrey, you did a half of 8 times 8. Treat it like they were both 8, even though you found 15. I'm not sure why. You know, obviously the legs are not both 8. One's 8. You found one to be 15, so plugging those in or base in altitude.
Just a level of entry.
Kendall, what was your answer?
68.
You did, okay, so you took this base, this leg, and the hypotenuse, but the hypotenuse isn't perpendicular, is it? So it can't be the altitude. So that's what happened, same thing, Quentin, with you. We got to dig a little bit deeper, right? Again, hypotenuse times leg is not the same as base times altitude or leg times leg, right? So again, if you'll start with a formula, either one, frankly, either one, you would have gotten to the right point. And so start by writing out the formula, and that'll guide your thinking. All right, any other questions on number 6? All right, number 7. It says the base of a rectangle is 12 feet and the diagonals are 15 feet. Find the area. Now it's a rectangle. So what formula do we need here, class? R equals BH. And I told you that the base was 12 feet. So we're off to a great start here. We already know the base. All we're missing is the altitude, but I didn't tell you the altitude, did I? No, that would have been in junior high, right? We're so much further along than junior hires. So instead of telling you the altitude, I told you that the diagonals, either one, because they're equal, I'm just going to draw this one, are 15 feet. Once again, like with the last problem where I needed the altitude or that other leg, I'm going to need the altitude. And how do we find the altitude, class?
Pythagorean Theorem.
Pythagorean Theorem. Once you draw that diagonal, you form a right triangle. You know 2 sides missing the third side. What is this third side?
372.
Ooh. Find it quickly using Pythagorean Theorem at your seats if you didn't already get it.
Oh, I see what I did. Okay.
There we go, 9 feet.
That was close. I had 352. That was pretty close.
All right, and so then we multiply base times altitude to get class an area of?
How did you do it?
Feet squared. There we go. From our times tables in elementary school, 9 times 12 is 108. Feet squared. Questions on number 7. Now again, for some of you, it's more about seeing the work. If you had written out formulas, even if answers were wrong, I don't care about that. As long as I'm seeing work. When I see no work, I construe no effort, and that's where I've got a problem. Yes, sir?
Wouldn't that be 45, 90?
In a square, because the legs would be equal, yes. Here the legs aren't equal.
That's a 60-30.
It's not a 30-60.
Oh, no, you told us not to.
Right, yeah, no, I don't know anything about 30 or 60. In fact, I actually know that it's not 30 or 60. I could actually find, this is actually 53.1 degrees approximately, and this is approximately 36.9 degrees, just in case you were wondering. You're going to learn in senior pre-calculus how we would do that, but yeah, that's, it's definitely not a 30-60.
He's flexing his brain on us.
Yeah. Well, I'm just letting you know you're going to learn how to do these things later. Questions? So I don't know anything that I'm not going to teach you later as far as that's concerned. Questions? All right, make sure you are putting effort into the homework, not waiting till today to start working on it.
I forgot about it.
Yeah. All right, questions? All right, hopefully that did you some good, but I'm a little skeptical of how much good it actually did you. Turn to page 244, and let's continue working with these area formulas that we need to have memorized really, really well. What's the formula for a rectangle, Ethan?
R equals BH.
Good. What about a parallelogram, Genesis?
Q equal B 1/2.
Ooh, just BH. What about a triangle, Kendall? T equals a half BH. What about a square, Chris?
SQ squared. SQ equals S squared.
Good. SQ equals S squared. What about a trapezoid? Give me one of them, Audrey. T TR equals HM. So smart girl, she takes the easy one, the lazy one. Good. Good job, mathematician. That sticks Quentin with the harder one for the trapezoid. Good. TR equals 1/2 H times B plus B prime, which frankly we're going to use that one more often anyway. And then introduced a couple of new formulas in the last lesson to you. The rhombus.
RH equals 1/2 D1 D2.
Good. RH equals 1/2 D1 D2. And then the right triangle, which doesn't really need its own formula, I don't guess, but we'll find it comes in handy a little bit later on, Genesis.
1/2 times leg 1, leg 2.
Good. Half leg 1, leg 2 for the right triangle. We're on page 244, and we ended our lesson last time with a very unsatisfactory problem. It was a crazy decimal, and then we had to take a square root of that crazy decimal, and it was just an ugly, ugly answer. We're actually going to pick up with that in number 13 now, page 244, and read number 13 if you would, Chris.
What must be the altitude of the rectangle whose base is 16 inches if it is equal to the triangle in exercise 12?
All right, so we have two figures mentioned to us here, Chris. First, they mention we've got a rectangle, and they tell me something about the rectangle. They tell me that the
base is 16 inches.
And they ask us to find the
Triangle, or altitude.
The altitude, right? That's the question. What's the altitude? But then they tell me something else about the rectangle. They tell me that this rectangle that they mentioned is going to be equal to a triangle from the previous problem. So now let's look back at the previous problem, Chris. What do they tell me about the triangle in the previous problem?
The base is 18.6 inches. The altitude is 12.4.
So they give me the base and altitude of the triangle, and they tell me I'm going to have a rectangle that's going to be equal to the triangle, and its base is 16 inches, and they want to know how big is the altitude. Do you see what we got going on here? And anytime we're dealing with areas, class, it's going to help us to write out the formula. I know, for instance, that the area of a triangle, class, can be found using the formula 1/2 BH. And I know the formula for the area of a rectangle can be found R equals BH. I'm going to call this B sub t for base of triangle and H sub t for altitude of triangle. I'm going to call this B sub r for base of rectangle, H sub r for altitude of rectangle. You don't necessarily have to do any of that, it just helps to make this a little clearer. So that means we'd have half B sub t, H sub t, and B sub r, H sub r, right? But if they tell me these figures are equal, if they tell me that the triangle equals the rectangle, then what that means is that a half B sub t, H sub t, class must be equal to
B sub r, H sub r.
B sub r, H sub r. I know B sub t, I know H sub t, I know B sub r. All I'm missing is H sub r. Set your seats, plug in the numbers, find the answer. You'll definitely want your calculator for this one.
You already know.
Just use this. And it does not come out evenly, but the decimal does stop. So it's not a repeating decimal, so we're okay. And it's not a irrational value. Call out H sub r once you found it.
7.2075.
I'm dyslexic. There we go, 7.207. Let's make that a fraction. You know, that's a crazy thing. Let's make it a fraction. Ooh, what is that fraction?
7 and 83 over 400.
Yeah, 7 and 83/400 inches. I think I like the 0.2075 better, actually. I'm usually a fraction guy, but not 83/400. And there we go. How many have gotten that answer now? Maybe you didn't get it as quick as Quentin, but you got it now. Does anyone need help getting that answer? All right, so again, you start by plugging in the numbers. Half of B sub t is 18.6. H sub t is 12.4. Equals 16 times H sub r, which I don't know. We're going to start by multiplying all that together. And then simply divide away the 16 to get the H sub r by itself. All right, so if you didn't do that yet, go ahead and do that now. Questions on how we can work with figures that are set equal to each other?
Can we do another one?
We're going to, yeah. Let's go ahead and take a look now, though, at number 14, which changes gears just a little bit, and somewhat reminiscent of the homework that we did last night. Go ahead and read number 14, if you would, Ethan.
One side of an equilateral triangle is 24 inches.
In fact, this sounds an awful lot like something we would have had on our last test, doesn't it? One side of an equilateral triangle is 24 inches. Find the altitude. Go ahead and work that through. And very similar to something we would have had on test 10. Quentin's already got it. What you got?
12 times square root of 3.
12 times the square root of 3. Quentin, did you do that completely in your head? And no picture or anything, because you could picture it in your head, I'm sure. What you pictured, I'm sure, was this, right? And you pictured this, and I'm sure you pictured that and that. 12, that's x. 24, that's 2x. This has got to be, so it's got to be, if this is x, and that's 2x. And what unit, of course?
Inches.
Inches. I think you actually might have said that. How many also had 12 times the square root of 3 inches? Because again, in an equilateral triangle, the top angle is 60 like all the others, which means it's bisected into 30s. And the base angles are 60. Questions on that? Now, do number 15. And what formula do we use here, Genesis?
Or equals 1/2
Good, T equals a half BH. This isn't actually a right triangle. There are a couple of them, but we're not really looking for right triangles, just a normal triangle. And so a half times base times altitude, where we know the base is 24. Again, don't get distracted by the 12. The base in its entirety is 24. Then we will take half of 24, I suppose, times the altitude, which we just found to be.
12.
And of course, we go ahead and take the half of the 24 to get 12. And what's our answer?
144 times square.
Good. 144 times the square root of 3, and that was inches. So inches squared. There we go. How many had the 144? Square root of 3 inches squared. Questions on number 15. Let's take a look at number 16, and go ahead and read that for us, if you would, Kendall.
Okay, area of an equilateral triangle is 48 square inches. Find one side and the altitude. Suggestion: let 2a equal one side and express the altitude, and then area in terms of a and solve.
All right, so once again, we've got an equilateral triangle, but we don't know how big anything is. All we know is the area is 48 inches squared. And so it gives us a tip, Kendall. It says represent the length of each side as 2a. Which means then that when I draw this altitude, Kendall, each piece is going to be a. Which means, Kendall, the altitude has to be helper class?
8 times square root of 3.
8 times the square root of 3. Whatever this is, even if it's an a, right? If it were a 5, 5 square root of 3. If it's an x square root of 3, it's an a times the square root of 3. And anytime we deal with area, it's good to write the area formula, Audrey. What do I put in for the t, class? Right, I know the area. When you know the area, plug it in for the capital letter. That is the area. That's where the 48 goes. What do I plug in for the b?
2a.
The base is 2a. What do I plug in for the h?
A times square root of 3.
Questions? Let's go ahead and solve. Though there's a little simplification we can do kind of up front here, Chris.
Oh, okay. I didn't do that right, but take half of it, you would get a.
Right, let's just take half of the 2a and make that a plain old a, so that when we multiply, Chris, it comes out pretty easily.
A squared times the square root of 3.
There we go, all equal to the 48. Now this is where it starts to get a little bit ugly. What am I going to have to do next to get the a by itself?
Square
Square
everything.
and then take square root.
I could do that.
Square everything.
I was going to divide away the square root of 3. I think that's probably going to be the
Smart.
easier method for us here. And if I divide away the square root of 3, that gives me a squared equals 48 over square root of 3. Just like if I had, let's just say 20 equals 5x squared. We would say let's divide away the 5 first, correct? Right? Well, that leaves the x squared by itself. Well, here it wasn't a 5, it was a square root of 3. Let's still go ahead and divide that away. Little algebra review here. But you're not allowed to leave radicals in the denominators. Going back to our algebra days, we're going to have to rationalize that. Which, the only way to do that is actually to take the square root. But can we take the square root of 3, class?
We'll take the square root of 1.
We can change this, though, to a square root of 9 if I multiply top and bottom by square root of 3. We've done this a lot lately, haven't we, because of 30, 60, 90s. So my numerator here becomes what, Ethan? 48 times the square root of 3. And the denominator becomes, well, square root of 3 times square root of 3. Genesis gives us square root of 9, which, of course, is just plain old 3. And then I can further do a little bit of reducing here. 48 divided by the 3, class. 16. So we end up with a squared is 16 times the square root of 3. Well, here we would get x squared equals 4 if we divided away the 5, right? What would I do next? Take the square root of both sides, right? Well, what do you suppose I have to do here? Take the square root of both sides. Of course, when you take the square root of a squared, what is that going to give us, class? A. The square and the square just cancel. Here's where it gets a little bit dicey. And algebra students from last year who only made it to algebra 1, you haven't seen this before. Veterans of algebra 2, this is something you've seen. When you take the root of a radical, you start by taking the root of the coefficient. That's easy. Square root of 16, class, is just 4. But when you try to take the root of a root, algebra 2 grads, what do? You multiply the indexes together. So the square root of the square root of 3 would become, multiply them, class, the 4th root of 3. And that's our value for a. Now, you're not going to have to do anything like that in a quiz or test, right? But this exercise gives me a chance to review for those who have had algebra 2. And for those who've had algebra 1, this is something you're going to see in algebra 2, but it's not hard, right? If I took the 5th root of the cube root of m, what would that be?
15 times square root.
The 15th root of m. Yeah, just multiply the index. So it's not a hard concept. It's just kind of a weird concept that you all hadn't seen yet. All right, that's A, but that's not what the problem said to find. What did the problem say on number 16 to find, Kendall?
Find one side and the altitude.
Find one side and the altitude. Class, how big is each side?
2a.
2a. So how big is one side, class?
8 times the 4th root of 3.
8 times the 4th root of 3 inches. And then it also said, this is where it gets really fun, find the altitude. Hold on now. The altitude, class, is represented
8 times square root.
So I need to take my a, and I would need to multiply it by the square root of 3, right, to get the altitude? But all of you should remember this from algebra. Can you multiply radicals with unlike indexes? No. So the strategy you might recall was to blow this up. Instead of the square root of 3 to the 1st, blow this up into a 4th root by multiplying the index by a 2. But what you do to the index, you had to do to the exponent as well. And so this would become 4 times the 4th root of 3 times the 4th root of 3 squared. In other words, the 4th root of 9. And now we can multiply. So what is the length of my altitude?
4 times the 8th or 16th root.
Oh, careful. When you multiply, you just keep the index the same.
4 times the 4th root of 27.
Now again, I'm not going to give you something like this on a quiz or test, but I like working the problem because it gives me a chance to review some things that you learned last year. It's been a little while. Questions on this?
If I saw that on a quiz, I think I just handed it the answers
Let's
on
give
it.
it.
All right, questions on the radicals. Been a little while, so I want to review radicals with you. So for those of you taking Algebra 2 next year, that's going to be a great review for you. Those going into pre-calculus next year, we're not going to do that much with radicals in pre-calculus, frankly, so, but still a good review for you. You might see something like that on ACT or SAT testing. Well, let's go ahead and move on to a much easier problem, number 17, and Quentin, read it for us.
Find the area of the rhombus with the diagonals are 12 inches and 16 inches.
All right, that should be very easy if we remember the formula for the area of a rhombus, class.
RH equals 1/2 D1 D2.
RH equals a half D1 D2. Thank you, Ethan. All of you working number 17. Bless you. And Chris, what'd you get for your answer?
96. Inches squared.
Good, 96 inches squared is correct. Now we have that same answer. 96 inches squared. All right, questions on how to work that one? Anyone need to see it worked out, or do we all get the answer? All good? All right. Now number 18 says, find the altitude of the rhombus in exercise 17. All right, let's think about this for just a minute. They gave us the diagonals, right? So here's a diagonal of 16, was it?
Yes.
And here's a diagonal of 12. Now we know the diagonals are going to be bisecting each other, and they're going to be perpendicular. So I know that this 12 becomes 2 pieces of 6 each. And my 16 becomes a couple pieces of 8 each. And we know that the area of the rhombus is 96 inches squared. That's what Chris told us. We all got that answer, correct? But it wants us to find the length of the altitude. Now you can use the altitude with the area of a rhombus, can't you? Because a rhombus is a parallelogram. So I could say that RH equals BH, base times altitude, right? Just like a parallelogram. And since I know the area is 96 inches squared, if I only knew the base, I could find the altitude, right? At your seats, find the base. Got this quickly as well, a few other people getting it. What do we have to do to find the base, class? Use the Pythagorean Theorem, right? Because essentially what I'm finding is the hypotenuse of this little right triangle. Chris, what is the base?
100. It's 10.
10, there we go, take the square root. So we end up with 10 inches.
9.6.
So, class, to find the altitude, we just divide. And what do we get, Chris?
Something really depressing. 9.6.
9.6, that's not so bad. 9.6.
Square inches.
Just plain old inches, right, for the altitude. Questions on how we could use both area formulas. We start with the D1, D2, but once we know that, we can actually use that to then turn around and go a step further. Questions on that? We've been doing this repeatedly now with these figures, haven't we? Where we were take an initial step and then go a little bit deeper, go a little further. Questions on number 18. Let's drop down now to number 21, and kind of an interesting problem here. Go ahead and read. There's quite a lot to read here, I know, but read that for us if you would, Audrey.
Find the area of the triangular tract of land. The following measurements were made. EW being an east-west line. DB equals 88 yards. VA equals 66 yards. AF equals 110 yards. FC equals 99 yards. Find the area of triangle ABC. DBC and FC being perpendicular to W.
All right, so like a surveyor might be surveying a tract of land. He gets a perfect west-east line, which we will call WE for west-east. And along this west-east line, there is a point where this triangular tract of land happens to come down right on this east-west line. The rest of the triangular tract of land is not set up perfectly east-west or anything like that. But from each of the vertices of this triangle, he could draw a perfect north-south line, which of course would be perpendicular. And then a perfect north-south line here, which of course would be perpendicular. And call these lines, for instance, BD and CF. And of these lines, we got a lot of them here, Audrey. Which are the lines we know? All right, and the question is, what's the area of this triangular piece of land? Thoughts? Yeah.
We can use Pythagorean theorem. Wait, I don't want to. I'm not saying I want to, but we could use Pythagorean theorem to figure out the two sides, and then
The two sides, AB and AC?
yeah. And
Yeah,
then,
absolutely. Let's go ahead and do that. They actually will work out, this one will work out evenly for sure. I don't think that one will. I'm not sure though.
I didn't want to do this the other way.
You have another way you thought of?
No. I just don't want to do it.
Oh, okay. Well, let's do it anyway. Find AB first of all. Use Pythagorean theorem. Go and find AB.
One time.
And I heard it just a second ago from Chris.
110.
Right, this comes out to 110 yards. Right, take 88 squared plus 66 squared equals, and then take the square root.
Oh,
Now, I don't know that this one comes out evenly, does it?
147.9898.
Oh, so it comes out irrational, doesn't it?
Yeah.
What was it before you took the square root? 21,901. All right, so this is the square root of 21,901 yards. I might be able to reduce that, but probably a mess. Well, you look at this. There's an 11 here, and there's an 11 there, right? So there's probably an 11 in there. Try dividing this by 121. 21,901. Try dividing it by 121.
181.
It comes out evenly. Okay, so this is the square root of 121 times 181, right? So this becomes 11 times the square root of 181 yards. Okay, so we can reduce that down a little bit.
Not enough.
Here's the problem. If this were a right angle, if it were a right angle, then I would be able to say half leg. Leg would give me the area of the right triangle. But do I know that that's a right angle? Nope, I don't.
So
Which means, by the way, that I don't know which of these might be considered the base and where the altitude would be.
I hate it here. That looks a tad bit scaly to me.
Yeah, I'm thinking kind of scalene-ish, kind of acute triangle myself. I don't see anything special. No 30, 60, 90, or 45, 40. There's got to be a way to find the area of that triangle.
Oh, wait. Oh, wait, never mind. We can get the base of BC.
Could we?
Yeah. Good.
How?
Because that's a parallelogram, right? No, it's not. Never mind.
Yeah, it's not a parallelogram, is it? What is it, class? What is, Chris, I assume you were talking about DFCB, the whole thing, right?
Yeah.
What is it? It's not a parallelogram, class, but it must be a
Quadrilateral.
trapezoid. It is a quadrilateral, but more specifically a trapezoid. Wait a second. So, this whole thing here is a trapezoid. Thoughts? We do have a formula for trapezoid. What is the formula for a couple of them, in fact. What is the formula for trapezoid? Now, here's the question, Quentin. I know we're kind of getting away from our triangle for a minute here, but do I know HB or B prime? Yes. What's B? Ooh. Class, what's B?
Oh, no, it would be W and E, not just D and F, right? It's not, because it's not 176.
187. It's on the WD and E.
You said 187. Where did you get that?
BD and C.
You added these two, let's see, they're both perpendicular to the same line, right, class? Which means they are parallel to each other. Oh, these are the two parallel sides. These, class, are your bases. So the sum of the bases is the 187 that Quentin gave us. So what would be the altitude?
93.5.
Ooh.
Okay.
If this is a base of a trapezoid, base, base, we need an altitude, right?
So 88 plus 99 is 187.
That's the sum of the bases. This is the altitude, isn't it? It's perpendicular to both bases.
177.
This is a right angle trapezoid. So the altitude is, class, 176. So we can find the area of the trapezoid if we wanted to, right? Because we know the altitude is. Here's the question: does it help me to get all of this area?
No.
Yeah.
I hope not.
Yes. How?
You could do that, and then you could do that equals a triangle.
What is that?
Okay, so let's go and do this on your paper, or on your calculator real quick. What is the area of the entire gigantic trapezoid?
16456.
16456 is what I heard?
16,456.
16,456 square yards, correct?
Correct.
Now, you said something about triangles. How many triangles are in the picture, class? 3. And we know that the area of the trapezoid is equal to all 3 triangles added together, correct?
Yes.
Thoughts?
I don't like where this is going.
Well, you already know the area of 2 triangles.
I can get the area of 2 triangles because these are both what kind of triangles, class? Right triangles. So, at your seats, 1/2 leg. What is the area of triangle 1?
110.
No, that's the hypotenuse. What's the area of triangle 1? Stay with me. Brecken, you can leave. Just shut the door behind you, please.
2,904.
I heard 2,904. Someone verify? Remember, 1/2 leg. You know one leg's 66. You know the other leg's 88. 2,904. All right. What's the area of triangle 3? Someone verify? Again, it's also going to be a 1/2 leg. So a half of 110,999 was what?
I can verify.
5445. 5445? Okay. All right. So what's the area of triangle 2?
Add those 2 together. Subtracted from
Right. Subtract this from the 16,456. And what do we get? I heard 8,107.
Yep.
8107.
Yep.
Someone verify?
I verify.
I got several people coming out with that. So sometimes you can't directly find the area. We couldn't do it. But we could find the area of a larger figure and subtract unwanted area away. A little bit of creativity. Your homework this evening is going to give you a chance to use a little creativity. Jamie, if you'll go back, actually I'll probably put it in the description again since it's been a while, but if you have been watching on YouTube and are using the handouts from the second semester, it's handout 13. Second semester handout 13, but Jamie, I'll put a link to that second semester handout collection. You'll want to do page 13 from that collection. And we'll dig a little deeper on the homework here and practicing with this. We do have a quiz over these areas in our next lesson together. All right, have a wonderful rest of your day. You are dismissed.